In this video, we're going to learn how to solve trig equations, so meaning tangent or cosine or sine of some angle equals a number. How would you solve that? And there's basically a four-step strategy. We'll start by using the same strategy we use for basic equations. And here's what I call the two cardinal rules of algebra, and they're pretty simple to remember. Whenever you're trying to solve an equation, you see what's being done to the variable and you do the opposite. So for example, if I wanted to solve 3x equals 15, I see what's being done to x, it's being multiplied by 3, and I do the opposite, which is divide by 3. Why do I do that? Because these will cancel each other out. And then the other thing is whatever I do to one side has to be done to the other, and we get our answer x equals 5. So it's the same exact idea with trig. We see what's being done to the variable. In this case, the variable is theta, so on number 1, and we do the opposite. What's the opposite of taking the tangent of something? And a lot of people would say, well, it's dividing by tangent, but actually it's not. I'm just going to rewrite this bigger. The tangent is not a number, so we can't divide by tangent, we can't multiply by tangent. The opposite of taking the tangent is taking, we've talked about this, it's taking the inverse tangent. Those are opposites. That's what inverse means. It means opposite. So if we take the tangent of something and then we take the inverse tangent, those cancel each other out. And then over here, we'll take the inverse tangent of the other side, because whatever we do to one side has to be done to the other. And now on the right side, all we have is theta. On the left side, this is going to give us an angle. Remember, inverse functions give us an angle. It tells us what number has a tangent of negative root 3 over 3. And you can put that in a calculator, or you may recognize that from the table that we memorized, the 30, 45, 60 table. That actually turns out to be 30 degrees as the reference angle. But it's negative, so if you put that in a calculator, you'll get negative 30 degrees. Okay, so that's our first step. We take the inverse and we find a reference angle, or in this case, the angle of negative 30. So we're done with this. Second step is we have to use our acronym, All Students Take Calculus, to figure out where is the other angle. Because there's actually this question is asking us between 0 and 360. There's actually two places between 0 and 360 where tangent is negative. And I'll show you where both of those are, because that's what the problem is asking us. Solve for angles between 0 and 360. So ASTC, we found out that our reference angle is right here at 30 degrees. Okay, that is the angle. If we're going clockwise, it would be negative 30, but I'm just call it 30. So the question is, what is this large purple angle that I'm drawing right here that goes all the way around except for 30? And the answer is it would be 330 degrees. 360 minus 30. So that's one solution, but there's another solution between 0 and 360, so let's find that. The other solution would be the other zone where tangent is negative. It's negative in the cosine in the sec quadrant. It's also negative in the s or the sine quadrant. And that means it's going to have a reference angle again of 30. So the question is, what is this orange angle right here that I'm drawing? So it's this one. Let me draw it in black so you can see it better. It's this black angle right here except for that last 30, and that is 180 minus 30, or 150. So those are the two solutions. We can easily check that on our calculator. So if we do the tangent of 330 or the tangent of 150, we should get the same answer, negative root 3 over 3, and as a decimal I think that's like 0.59 or something. Close enough, 0.57, 0.58. So let's test the other angle that we had was 150. This should be the exact same answer if we did it correctly. And let's see, and it is. Okay, so those are our two solutions. We're not quite done because we need to have answers in radians also. So this changed into radians times pi over 180. By the way, the reason I'm putting 180 on the bottom is because we're in degrees. We want to cancel out the degrees. Okay, when you simplify that, you get, 33 and 180. So what goes into both of those is 3, or 30 actually. 30 goes into that 11 times. Goes into that 6 times. So in radians, this would be 11 pi over 6. And then down here, this one, if you change it the same way, it turns out to be 5 pi over 6. All right, so that takes care of this. And this, here's the other thing. What does it mean to solve it for all angles? Here's what that means. It basically means, like, if I were here, let's say at that green dot, if I were here at 150, and then it went all the way around the circle again, I added another 360 to 150. If you add 360 to 150, you would get 510 degrees. So I want to show you in a calculator what is the tangent of 510, and you can probably already guess what it's going to be. So the tangent of 510, when we do it, sure enough, it equals the same thing. So how can we write our answer so that we are accounting for every single angle? Because you can go around, you don't have to go around once. I can go around 75 times, and then it would be 150 plus 75 extra 360s. So here's how you can write that. You can say theta is equal to 150 degrees plus 180, and I'll tell you why in just a sec, plus 180 times n. So here's what that means. First of all, why am I adding 180? Because the difference between 150 and 330 is 180. So every time I'll trace this. Yeah, I'm running out of colors here, but I'll trace it in kind of this pink color. Here's 150. Tangent, we already know there is 0.57 or negative 0.57. If I go 180 degrees to right here, that's also 0.57. If I go around another 180, we're back at negative 0.57. Another 180, we're back at negative 0.57. So obviously, we want to say that it always equals that number at 150 plus all the 180 degree turns that I go around the circle. And that's what this means right here. Okay, 150 degrees plus, every time I do another 180, I'm back at the same tangent value. So n stands for the number of rotations that I go after 150. If I go one rotation, if n equals 1, well, that gives me this 330 value. If I go two rotations, so that's a 360, that gives me the 510. So this is what that extra part means. It means find the original answer and then add to it basically the period. The period of tangent is 180 degrees. Alright, so now that we have the solution for tangent, let's try and get the one for cosine also. And this one's a little bit different because 0.81 is not part of our table. So in this case, we're going to have to simply plug that into a calculator. So once again, we want to solve for theta, so we need to we need to cancel out the cosine, and the opposite of cosine will be inverse cosine. So let's do that to both sides. Let me just write this a little bit bigger. So cosine of theta equals 0.81, and we will cancel that out by taking the inverse cosine. Sorry, the handwriting's a little bit messy there. Inverse cosine of 0.81. So here's what you can do on the calculator. You can go to second cosine 0.81, and this is going to give us an angle measure. It's not going to be 30, 45, or 60 because this is kind of a random function here. Let me delete that for a sec. Okay, so this is going to give us the angle 35.9 degrees. So let's come back here and we'll just draw a picture of this. So here's our unit circle. 35 degrees is about right there. And remember, cosine is the x-coordinate, so this means this has an x-coordinate of 0.81. So the question is, where else on this graph would also have an x-coordinate of 0.81? Where else is cosine positive? And the answer is cosine is positive here, and it's also positive here. So that means this right here, notice that these are on the same horizontal position right there. That also has an x-coordinate of 0.81, which means this angle is also 35. Actually, let me put the decimal there, 35.9. So one answer is theta equals 35.9 degrees. And the other answer will be theta equals this purple angle, which goes all the way around except for that last 35. So that would be basically 360 minus 35.9, and that's equal to 324.1 degrees. Okay, so those are our two answers between 0 and 360. You can change them into radians pretty easy, so we could do 35.9 times, this is in degrees right now, so we want to put degrees on the bottom, times pi over 180. And for this, it's probably easier to just get a number out of this. I'll show you how to do this. So 35.9, and then times second, and that's right above that division sign, times pi, and then we're going to divide that by 180. And normally you could put parentheses, but in this case the order of operations won't make a difference. So that is 0.62 or 0.63 radians. Okay, so 0.63, and we don't have to put this in terms of pi, we can just say the number 0.63, because remember, if I said pi radians, pi is a number, pi is 3.14. So 0.6 is like, it's about a fifth of pi. A fifth of pi is around 36 degrees. So that's this solution, and then this one in radians, we would do the same thing, 324.1 times pi over 180. And you can kind of tell, well, think about it, all the way around a circle is 2 pi. That's almost all the way around. So we should get a number pretty close to 2 pi. And 2 times pi, or 2 times 3.14, that's the same as 6.28. So if we're doing this correctly, we should get a number pretty close to the number 2 pi, meaning pretty close to 6.28. So let's try that. So we're going to divide this by 180. And then here's our answer. Our answer is pretty close to 6.2, 5.7, let's say. So our other answer here would be 5.7 radians. Okay, so that takes care of this. How do we find it for all angles? Here's how you can do it. Let's just do it in degrees to keep it simple. So in degrees, here's how we would say it. Theta, we're going to have two answers. Theta equals 35.9 degrees plus 360 degrees times n. So what does that mean? That means if I'm at 35 degrees right here and I go around 360, I'm going to have the same cosine if I go around 360 again and again, and all of those rotations are kind of stood for by n. And then the other example, the other answer would be 324.1, again plus 360 degrees times n. So that means if I'm down here, it's getting a little bit messy, so let me redraw this. 324 is right here, roughly. There's my 324 degree angle. If I go around another 360 and another 360 and another 360, that's what this means right here. So that accounts for all solutions.